All right, my friends, let's take a look. If e to the negative x ever gives you any grief, it would probably make sense to write it as 1 over e to the positive x. Okay, so let's just check and see which indeterminate form do we have here. So let x approach infinity on 1 over e to the x, and you have a value that's approaching 0. And then let x approach infinity on square root x, and you have a value that's approaching infinity. So we have the 0 times infinity indeterminate form. Now, I hope it makes sense with this one that 0 times infinity is likely just an infinity divided by infinity indeterminate form, kind of in disguise. So if that 0 times infinity didn't make sense as to why it's indeterminate before, hopefully it does now after you see it within an example. Okay, so the point is that we have the green light to use L'Hopital's rule. And so now really quick though, it's actually not until you have your limit written in the form, the limit is x approaches c of one function of x divided by another one, that you have in a way the second green light to use the rule. So you need to have an indeterminate form first of all, but then you also need to have the limit written in this format to apply it, and that should make sense anyway. But all right, so now I'm going to go ahead and apply L'Hopital's rule. So I'd have the limit as x approaches infinity. Square root of x is x to the 1/2, and so if I use power rule on that, I think I get this, and then the derivative of e to the x is just e to the x. All right, my friends, and I have a compound fraction. I'm just going to flip and multiply to simplify it out. There we go. And now let the remaining x's approach infinity, and you end up with 1 divided by a number that is approaching infinity, which would squeeze your value to 0. There we go. All right, hopefully that makes sense, my friends. Okay, for part B, let's let x approach infinity. 1 over x would approach 0, and e to the x would approach infinity. So here we are, we have this version of an indeterminate form again, which, if you do write it in the format we need it to be in anyway, then a little more evidence that 0 times infinity is really just infinity divided by infinity in disguise. So anyway, so now that we've got both green lights to use L'Hopital's rule, let's go ahead and apply it. Derivative of e to the x is e to the x, and the derivative of x is 1. Let x approach infinity, and you end up with infinity over 1, which is infinity. There you go. All right, my friends, hopefully that makes sense. We have one more example. All right, I'm going to have you consider example 4, evaluating the limit. Evaluating the limit as x approaches infinity of the quantity 1 plus 1 over x to the x. See how it goes? Check in with me in the next video.